Hi everyone, welcome. In this video, we are going to use Excel to do clustering, which is a descriptive data mining technique, and it's an unsupervised method. It is more of an exploration of your data set and finding similar observations in your data set and group them together. So if you think about a sandwich, and if I search for a sandwich in Google, and I'll find a lot of different types of sandwiches, but I may be able to classify them like Google did here. So grilled sandwich, cheese sandwich, etc. And then I will be able to put them together based on their ingredients, their bread, whether or not the bread is toasted, etc. And but I may also find some clusters with a minimum number of sandwiches in them. Those could be the ice cream sandwiches, right? So that is kind of maybe a cluster with a small number of units in their observations in that, and that would be an outlier group, and you may be able to identify your outliers by that way as well. So Excel is not going to be the best method to use, but it is going to help you understand what clustering is. So assume that we have these different types of products and identified by their stock keeping units and average sales amounts for each product and the standard deviation of the sales. And some standard deviations are high, some of them are low, and some average sales are high, some of them are low. The standard deviation by itself may not be a good variable to use when you are doing clustering because the standard deviation, the magnitude is when you compare it against the mean value, the average value, it makes sense. It kind of explains or just provides you the magnitude of the standard deviation compared to in relation to the sales amounts. You can think that as, for example, if you have 10,000 as a sales and the standard deviation 100, which is kind of small, but if you have sales 100 and standard deviation 100, which is kind of large. So in that case, instead of using the standard deviation, you may want to use the coefficient of variance, which is the standard deviation divided by the average of sales, which is the ratio of the standard deviation by the sales. So these are the numbers that I've found for the coefficient of variance. So if I look at the average sales and the coefficient of variance now, and using these two information, I want to classify my observations. So I may be able to do that by just creating a scatter chart. And I can just create a scatter chart for these two columns. And I'm able to see that there are three distinct groups. Why? Because I created this data set myself. It is a synthetic data set. It is not a real data set. So just to explore the idea, it looks like there are eyes and the nose possibly. So what's happening here is that I want to find the cluster means, and because there are only two variables, I can see that there are three distinct clusters here. But what if there are more than two variables? If there are three variables, you are not going to be able to see this cluster means, then maybe you need a 3D plot. What if there are more than three variables? So you are not going to be able to visualize that, and that is going to be difficult for you to kind of identify the number of clusters or the cluster centers, etc. You need an algorithm to do that. So in that case, for the algorithm to work, what we need to standardize these variables. So here the coefficient of variance happens between 0 and 1.2, but these observations, the sales amounts are in thousands. So if I look at this, the distance between, for example, these 2 points here on the x-axis, maybe it's about 100 or something like that. But on the y-axis, this is less than 1, maybe 0.1 or even less than 0.1. So if I want to try to find the distance from any center of a cluster here to the points, and I am going to favor the x distance over the y distance, and I will not really care about the y distances at all because they are very minimal. So I will only pay attention. The algorithm is going to put all the emphasis on the x distances, not the y distances. And that is going to create wrong results. So what we need to do is we need to standardize these variable observation values first before running the algorithm. Okay. So how do we do that in Excel? We just use the function standardize, and then it is going to use the x which is the value is, and then the mean of that column of that variable and the standard deviation of that variable. So let me just name them first. Okay, so here are my sales. So I just use Control Shift and down arrow. Then these are named as sales. Okay, it's already there. And then I'm going to also name the coefficient of variance. I may also have that. It's not there. Okay, so that is going to be CV. Name that. So in that case, I can just normalize my CV, the coefficient of variance, standardize. And the x is this value. The mean is the average of the CV and standard deviation of CV. Okay, then I am done with that. I'm going to use the same idea for the normalized sales, and instead of using that column, I'm going to use average of sales and the standard deviation of sales, and then this is going to be finding me the average sales and then standard deviation of sales, but not this one. I'm going to be using what? This value, average sales here. Okay, and sales, and then average sales and standard deviation of sales. So I'm able to find my normalized sales values as well. Then I'm going to double click on that and find my normalized coefficient of variance and sales values. Now I can just go ahead and identify my clusters using these values, not the original values. So distances are not going to be very far away from each other in terms of their scale here. So we could use this as standardized values. Now the problem with Excel is I need to determine first, start with the number of clusters. I decided that I want to use 3 clusters, and I knew that the 3 clusters would be better to use, and this is the k-means clustering. So I decided that it's going to be a 3 means clustering. If you want to use Excel, then you'll have to do 2 clusters, 3 clusters, 4 clusters yourself, and if you use some other maybe programs, you can do that in an easier way. And you can also use hierarchical clustering as well, and you may be able to find the best number of clusters. But let's just try to understand if we know that there are going to be 3 clusters. And I want to put this cluster means as one of them 0, 0. So these are kind of initial starting points for the cluster centers. And what I want to do is I want to find the distance of each observation that I have. I'm going to be use this tool. Let me just color them with your favorite color. Which one is favorite your color of yours right now? Let's just do green. Okay, so what I'm going to do is I'm going to use this tool, and I'll find the direct distance, the Euclidean distance from this observation to this center, and then calculate for the second center and the third center, and then I'm going to just decide which cluster center or which cluster to use for that observation. So I'm going to assign a cluster to this point based on the minimum distance. So I do that is I'm going to use the Euclidean distance. The direct distance is square root of what I'm doing here, SQRT of this CV value, the normalized CV value minus the CV's center for the first cluster. And then I'm going to put a $sign on that. Okay. And only that one. And then I'm going to square that. This is I'm finding the Euclidean distance plus I'll find this one minus the second center and put my $sign on it so that when I copy and paste, this does not go down. Okay. And then once that's done, I'm going to square that, and that's both of them are going to be under the square root. If there are more than 2 variables, you can continue adding these and finding 3-dimensional distance or 4-dimensional distance, etc. So it's just enlarging your square root function there. Okay, so this is the cluster. And let me just copy this here. And I'm going to just change this to, now I'm going to use this to cluster center values, and then for cluster 3, and it is going to be this, the third one. Okay, and that's done, and I'm able to find the distance from this point to the first cluster, and the second cluster, and the third cluster. And for every observation I found them, then I'm going to use the minimum of this 3, and the minimum is going to be 1.249, and I'm able to find the minimum distance, and we are able to find the minimum distances for every one of them. So it's time to assign the cluster. So you can use two different functions. One of them is XLOOKUP, which is a new function, and maybe some Excel versions wouldn't have it. It's easier to use. I'll just say 1.24 here. That's a lookup value. I'm looking for in this range here. And once I find them, I'm going to return the value, the matching value from here. And then the next thing is, if not found, there's nothing. I'm not going to do anything because we're going to be able to find it. And match is going to be an exact match. And then the search model, I'm going to assume that it's going to be default. And done. So the cluster 1, and for G2 and I2 and G1 and I1, I'm going to use my dollar signs here, so that when I copy and paste, this selection will not move down. So when I do that, what happened here? So was it, this is also selected, and then it was able to find that it is still the shortest distance to cluster 1. And is it all assigned to cluster 1? No. So the formula works, but it is not the correct assignment. Okay, so that means now we were able to put the clusters in there based on the minimum distances. Now, if we change this cluster centers, then the assignments of these clusters are going to change and be based on the minimum distance. Think that like maybe you are putting the retail centers and you're trying to find a distribution center to assign for those and find a location for a distribution center, and you can do the same thing. Okay, now I want to just visualize this. And how do I visualize is that I want to look at this normalized CV and normalized sales values, and I want to create a scatter chart. But what I want to do is I want to display them in different colors just to illustrate that the assignment of these clusters, I know that the perfect assignment is going to be 3 distinct colors for these 3 distinct groups, but that may not be the case because we have wrong cluster means. One of them is 0, 0, the other one is 0.5, 0.5, and the other one is 1, 1, and none of them are closer to these points here. So that means what we have to do is we have to use, just to color them, it's not going to work if you also highlight these clusters and then put your scatter diagram, which is the shame for Microsoft. They haven't really put the scatter charts with the distinct colors using the legends, and we have to do maybe an approach that is going to be a fix for that. So what we need to do is we are trying to find the CV versus the sales for each cluster. That means what we're going to do is we are going to display the normalized sales only for that specific cluster. So we need to put the sales amount for cluster 1 here, and maybe if it shows cluster 2, we will put the sales amount in here. So to do that, I'm going to use the if function. If, okay, so if this cluster is equal to here, then the result is going to be the normalized sales. Otherwise, the result is going to be NA. So you need to put an NA function here. Otherwise, if you just put a blank, it is not going to work. Okay, so that means we'll have to just put the NA function, which is another shame for Microsoft. Just fix this. And what we have to do now is we need to put our dollar signs in the correct order. And if you don't know how to use the dollar signs, I have another video that you could first look at that video and learn about the dollar sign usage, and then come back here after. So I'm going to put the K2. This one should go down, but not to the right. So it is going to be $K2. LMN, when I copy across, this one should just to be copied across, but it should not go down when I copy down. So this is going to be $1. And F2, we want this to go down, but not across. So that is going to be, again, $F2, and it's done. So this, because it shows cluster 1 here, it shows the value, but for cluster 2 and 3, it shows NA. And then we were able to do that. If you look at down here, this is cluster 3, and the value of the M sales, the normalized sales, is displayed for cluster 3. Okay. And if you have difficulty understanding this, you can pause the video and maybe try to understand it before proceeding. And this is just to display my clusters here. So I'm going to highlight the normalized CV values. And then I'm going to press Control and highlight this 3, oops, here. Okay, let's just do this one more time. Normalized CV values are highlighted. And then the clusters are highlighted as well. Then I'm going to Control Shift and down arrow. So I have highlighted 3 columns there and 1 column here. And look at the beauty now, the scatter chart. So we were able to find the clusters for sales data. Okay, good. And this is not a correct set of clusters, because what's happening here is we have the wrong data to start with. I mean, the wrong values to start with, not the data. So here, what's happening here is that for 0, 0, this point here, and it is assigning all the points, the blue points, right? So that's the cluster center 1. And it assigns all these points to this center. And then it assigns these, the orange ones into 0.5, 0.5, this center. And then 1, 1 center gets all these gray points. If I also want to put the centers there, it's going to take a little time, but let's just do that in very quick. I can just go to Select Data and add cluster center 1, and then the X values is going to be here X, and the Y value is going to be this, and I'm going to click OK, and I am able to find a cluster center 0, 0. That is for cluster center 1. Okay, so I can do the same thing for cluster center 2, cluster center 3, and I'm going to do that after pausing my video. Let's first just maybe make an edit to that, and then I'll pause the video and then just add the other 2. So for this one, just this one, I want to format this by just looking at the marker, and I'm going to make the marker the same colored blue. Okay, so it's going to be blue colored marker, and it is not going to have a fill, and then it is not going to have a fill there, no fill. And what else I need to do here is that I want to make that larger, and the marker options, I want to make a built-in marker with maybe one of these. Okay, size, let's just make it 20. 20 is a little big there, maybe 10. Okay, good. So this is the cluster center for these points, and I can just do the cluster center for the other 2. I'm going to pause the video, do that, and come back. Okay, so I was able to just put those here. The gray one is hiding there, so maybe it's getting scared. So let me just try another, the cluster centers. So I'm going to use maybe negative 1 and then negative 0.8, something like that. What it does is now it put the cluster center there, it assign now this point to this cluster. So the assignments have been changed and we can dynamically see those. Let's say this is going to be 1 and 1.5 and maybe 2 and 2. So we are seeing now that it is not the best way of clustering, but it is just illustrating the idea. So in that case, what we want to do now is we want to be able to find this total distances from each cluster, okay, and the assignments from the cluster to the points that are assigned to that cluster. And we'll find that by just using the SUMIF function. And SUMIF is going to take this range criteria and sum range. So the range is the clusters. So let me just move this a little farther away here so that this graph is not really going to affect us. Okay, so I put that there. And now we could just do this. So we are going to use SUMIF. The range is all these clusters there, okay? And then that's that. Criteria is cluster 1, and the sum range is going to be the minimum distances, okay? That is going to give us the distances for only the points from this cluster center to every point there, okay? So that is, now I want to put my dollar signs on this. Just the dollar signs on the numbers is sufficient. And do this here and close the parentheses. And 273 and 77 and 0.43. So why do you think the cluster 3 has very small total distance within cluster distance, indicating that it only goes and grabs this point, and that's the only distance. There is no other point as far as I can see there that's assigned to cluster 3. So this total distance is 351, and this is not a correct distance. If I change this cluster center values, and then the total distance is going to go down, and every single one of this cluster distances will try to be lower, but the objective is just to lower the total of them. And how does the algorithms, how did algorithms do this is that they are not using an optimization method that I'm going to be using here. They are using an iterative approach. So for example, assume that these points are the initial point that they have selected as the center of these clusters, and assigns these points to this center. And then what it does is finds a center for these blue points, which is not here, maybe it's going to be somewhere here, and then finds a center for the orange points, it's going to be somewhere here, and then find a center point for the gray points, it's going to be some right on top of this gray point here. Then it is going to look for the closest points to that new center. And it is going to be different from this, a new assignment. It is going to do that multiple times in iterations, and it is going to converge to the center, and it is going to provide the best center for each cluster, and it is going to minimize the total distance. So how can we do that is ourselves here. We are not going to write a macro to do that or something. We are going to use the solver. And under the data tab, there is solver. If it is not there, go to file, more, and options, and then go to add-ins, and under add-ins, Excel add-ins, and go, and just activate the solver add-in. If you have a Mac computer, God bless you, just go to Google and do solver for Mac computers, and you will be able to find the solver, how to install it. So once you have the solver in, we are going to have the solver menu there. And in the solver menu, what we're going to do is we are going to just use the total distance here and just click on that R13. We want to minimize that by changing these 6 variables. And then we are going to add a constraint to these variables. We know that the range of these variables, right? So they are like going into -2 in there. And maybe let's just add some limits so that the solver will not look for extreme values. So what we could say is that all of these are, we want them to be less than or equal to, let's say, we could just directly say the maximum of the values there that we are seeing in the coordinate axis, but I'm going to just put 5, okay? They have to be less than or equal to 5. I could put 4 too because it's not going up to 4. And then I'm going to add that. And I also want these points to be greater than or equal to -5, then okay. And I do not want my variables to be non-negative, so I may be able to get the negative values there. And the final thing I want to do is I want to choose the evolutionary solver. Because we have used some if statements there and some other things, a regular nonlinear solver is not going to be able to find us a solution. And even the evolutionary solver may not give us the best solution here, but because it's a small problem, it is going to provide us the best solution. It's already 26 minutes. Oh my God. Okay. So I'm going to click on solve and hope for the best. As you see here, the evolutionary solver is just going around and trying to find the best solution. It is trying to minimize that total distance, and it is going to converge after a while. It looks like it did converge to that 140.9 something value, and it is still looking for mutating the solution space, and it is trying to find maybe if it's stuck at the local optimum, then it is going to try to escape from the local optimum by just searching for other things. And it says it cannot improve the current solution, and we are able to find the best solutions here. So we are able to find the best here, the center there and center there. They are hidden, and the center there. And it looks like this blue point is closer to this center than this center based on these values. So we were able to find the clusters for this these observations using 3 cluster centers for these observations, and these are the cluster centers for the modified, for the normalized variables. Okay, so the observation values there. Now let's just look at this data. This is the clusters that we want, right? We have the clusters 1, 2, and 3 there. And what we want is we are going to now go to the stock keeping unit, and we're going to insert a pivot table there. And we want to get in the pivot table, we want to put the cluster. Okay, where is that cluster thing for the 2 variables? And I want to just maybe get this only up to the cluster. So I'm not going to just create this pivot table with every value there. So let me just delete this pivot table here. And then I'm going to just highlight the stock keeping unit here up to there, and then down, just select that data, insert a pivot table for that specific region in a new worksheet. And I take the cluster and I have 3 clusters there, and I want to look at the average sales. Okay, and then I want to look at the standard deviation or the coefficient of variance. So let me just look at the coefficient of variance values and the standard deviation there. Okay, and instead of finding the sum of those, I want to look at the averages. And the same thing for here, the averages and then the same thing for here, the averages. So let's focus on the average sales in each cluster and the coefficient of variance for each cluster. Assume that you were not able to picture this in, let's say this is multiple variable space, and you are not able to visualize it. You can still look at these numbers and come up with certain conclusions, and you can develop certain maybe policies based on these results. So what I see here is that I see that cluster one has kind of an average or on the higher end, the sales. It has lower variance for the sales. So these products, you have good sales amounts and then you have low variance in your sales amounts. Thus, these products are very valuable to you, right? So you know if you're going to be selling around 3,000, and these are the products that you want to pay attention to. The second cluster, the sales are low and there is a large variance there. So these products are, you're not getting a lot of money from these products, the average sales amounts, and there's also a lot of variance. So sometimes you are selling $1,200 on average, but sometimes you are selling much less and much more. There's a huge variance in there, but the average is on the lower side. And this cluster here, although you are having a lot of sales in here in terms of the dollar value, but you are also seeing a large variance. So you are not really able to predict maybe the values for the product stock keeping units in the third cluster, because the numbers are just in close to like 87% of the sales amount is the coefficient of variance, right? So standard deviation is very high. And as you see here, 981 is kind of not really telling you the truth, because this is based on the average. Here it's 0.79. This is a better number to look at rather than looking at the standard deviation itself. So now we are seeing that there are three distinct groups, and we can maybe treat these different types of products in a different way. And I can maybe look at cluster 3 and just look at this cluster group. And let me just look at which products are they. They are these products, and I can focus more on these products here, and because they are having higher sales. And I know that I don't need to worry a lot about cluster 1, because I am going to be able to estimate or predict the sales for this cluster better than the others, because there's a lower variance in there. Okay, so this is done for what? This is done for 2 variables, and we can also do that for 3 variables. I'm going to just keep it in here. I'm not going to solve this, but I recommend you to work on this and find the total distance for 4 clusters using 3 variables. So the sales, standard deviation, and quantity now. So this is the sales amount in the terms of the dollar value and the standard deviation of that dollar value. And these are the number of sales in here. And using these 3 columns, would you be able to come up with the minimum total distance? Once you find that, you can put that in your comments, and let's see if everyone is going to get the same values. In the next video, I'm going to show you how to do 2 variable and 3 variable clustering using Power BI and then R. You can compare the efficiency of the methods, and the R is the most efficient one, and the Power BI is more, I think, the nice looking one, and Excel is the one that gives you the background information, just removes all the black box idea, and just you know what you are doing in Excel. And I think it's the best teaching method for this data mining techniques. and using Excel on small examples and understand how they work. And you can then maybe generalize this to more complicated problems. And thanks for watching, guys.